difficulty with 11G3. Now, D3. Let's have a quick look. I think I went through question 1 with people, but we'll do it again because, you know, it's always nice. So make sure we're listening, please. All right, Jack, I'm ready to go. You're talking. So, a triangle ABC. AB is 10, BC is 7, CAB is 42. Hell's bells. All right, so we've got AB. I'm just going to draw 10. Okay, angle CAB. So that means this one up here, CAB, because B is here, C has to be somewhere along that line, but that is roughly 42 degrees. Do we agree? And then BC has to be 7 centimeters. Now this is where we can have multiple possible, oops, that wasn't very good, possible solutions, and we don't know what they are yet. So I'm going to just draw it going, what if it went all the way here, and so that is 7 centimeters. Yeah? Do we know anything else? Got 42, got 10, got 7. Find the 2 possible values for ACB. So I need to find this angle here. Yeah? Can I use the cosine rule? Why not? That's right. So to use cosine, I need 2 lengths and I need the angle in the middle, or I need all 3 lengths. So cosine's out. It is not Heron's because it doesn't mention area, and it is not area half whatever AB sine C because it doesn't mention area. Just said that. Correct? So away we go with our sine rule. And I'm going to start with sine theta upstairs. Why? Right, unknown upstairs. All over. What's the deal with sine? Pairs. Right? It's opposite length. So it's going to be over 10 equals? And now, we solve. So writing it down. Yep. Straight into theta equals. Oh. Yeah, I'm sure you just said cosine. I was like, what? As long as you don't make a mistake. So it was saying, do you want to go straight to sine to the minus 1? Sine 42, sure. But again, don't make a mistake. So to get rid of the divide by 10, we times by 10. And as Lily said, and Honey Lily, to get rid of the sine, your inverse sine. So pop that in your calculator. Luke, you've come late. Get your books out and open. Get a pen. Okay, so now we actually have to check. Every time we use the sine rule, we're going to check, could there be a second solution? So this is the tray difficult thing. You go 180 minus 72.9. It's the end of the day, 180 minus 72. I feel like it's Friday. 107.1. And now we add it to this angle here. Yeah? We go, what is 107.1 plus 42? 147.1, which is clearly less than 180. So therefore, both of these answers, right, this answer and this answer could be the angle. You're killing me. I know, but you then do another question, not type. I can see. I'm not blind. I'm not blind. Right, so notice 72, that would be this one. How do we get the other angle? This is where that's flicked out. What happens if we flick in? that would be the 107.1. Flick out, flick in. Right? I've still got 42 as my angle, I've still got 7 as my length, and I've still got 10. That's how I can get 2 solutions. Will you always have 2 solutions? Niet. No. How do I say no? 9. Which one? 9. 9! Question, I got to say, props up a lot of the time. If it's not a flagpole, it's a mountain. Okay? The issue is, did you ever do the thing out last year or in year 9 with the clinometers? Measured the height of the tree? And you had to measure to the base of the object. Now, what happens if you couldn't reach the base of the object? So you couldn't get here because there was a lake of piranhas. Just couldn't get there. You could then use non-right angle trig. So this is the situation. We want to find, can't keep chatting if you are at the same time. So we want to find x here. But if you look at this little triangle here, the right angle triangle, all you have is the 53 degrees, not enough information. If you look at the bigger triangle, same thing. You've got an angle, but you haven't got the whole length. So not enough information whichever way you go for right angle. So then you have to decide, would you agree? If you either found this one or this one, could you then find x? What has the best hope? Which one has the best opportunity to get or work out the length? Why the bottom one? But you don't know what it is. Can you see that this one is connected to this triangle, which has got lots of information on it? So that's the one we're going to go after. Oh. So please put a y here. You can't call it x, otherwise you're going to assume that it's the same length as the flagpole, and that's no good. I see a straight line. Walking in a straight line. What do we know about 180 degrees in a straight line? So what does this angle have to be? You've got calculators right next to you. That's got to be 127. Do you see where we're going here? If I was to draw this triangle without all of the flagpole, without all of the other stuff, this is y, this is 20, I've got this is 28, and I've got this is 127, and you want to find y. How could you do it? Yes, Luku. But don't I need a known pair for the sine rule? So I've got a pair here. Oh. Yes! Can you find this angle without any trigonometry? Yes! This is going to be 180 minus 27 minus 28. What is that, please? I think I just did it over there and I've forgotten. Was it 25? 25, thank you. Oh, my brain is mildly still working. Thank you, Izzy. You might want to check because I think I did that by hand, but anyway. So go ahead and, as Luke said, use your sine rule to find y. Who wants to set that equation up for me? Well, I know, yeah, we did that together. You carry on. Y over sine, let me see. Now, hang on, y over sine what, Ciens? Oh, it's, you know. Stop myself, sorry. Correct. Equals? Now be careful. If you say 20 over 25, you're going to be in strife because I know you meant sine. I know what you meant. That's okay. Therefore, how do I get rid of that? Divide by sine 28. We're going 2 times. Okay, so are we done? No, we're not. What was the whole point of this? We wanted to actually find x. So what we have now, if I looked at that little bit in here, we've got the 53. We now have that this length. Some people like to call that the hypotenuse, right? And we've got x. So now, if you want to, you can use non-right angle trig, but why not go back to our grassroots of right angle trig? Okay, we've got our opposite side, we've got our hypotenuse. What rule is that? Sine, but not non-right angle. So it'll be sine theta equals opposite over hypotenuse. My angle is 53. My opposite is x, 22.2. It is actually embedded in this because if you use this sine rule here, you would have sine 90. And guess what sine 90 is? 1. So it sort of cancels out, and that's how we get this. So non-right angle trig works for every triangle, but your right angle only works for right angle trig. Okay? So therefore, x, which is your flagpole, is going to be 22.2 times sine 53. 2.2. And someone will get me that answer. I can. Oh, too much. Is that okay? Please read number 2, draw diagram. And label diagram. So I don't know about you, but that little diagram with the lake and everything sometimes confuse people. So if you just draw it simple, we want to find x. So am I using the sine rule? No. Why can't I use the sine rule? There's no pairs. But what have I got? I've got 2 lengths wrapping the angle. I totally do. So this is your cosine rule. Now, Amy, you weren't here when we did all this, but we don't need to label. No, but you asked me about the whole A, B, C stuff. I don't care which one's A, B, and C. They have to be around the angle. Correct. The length is opposite the angle. I got you. Well done. The really long one. So, b squared plus c squared minus 2bc cos the opposite angle. And you, I'm telling you right now, are going to have to do, actually we will stand up. You will stand up and sing God Save the Queen if you forget to square root. You have to look it up. Attention, you'll just have this, and this equals x squared. I don't want x squared, so you must remember to square root. Otherwise, we're singing God Save the Queen. So, if you have done question 3, you are being silent. If you have not done question 3, again, you are silent watching so we can get out of here on time. All right. The golfer, we want to find out how far he's offline. So, it's this angle that we're trying to find. Yes? Now, really important, this angle is opposite that length. What I would like to think is we did these questions. Waiting again for people. We did these questions earlier on. So I would like to think you can flick back and look in your book or scroll up and look in your textbook. But here we go. We go cos theta, and we have to take the 2 lengths that surround the angle. So it's going to be 220 plus 340. So I would suggest, right, I reckon I can guarantee that there will be a question like this in your test. Right? Definitely having to use the cosine rule backwards. So please don't just copy this, because I'm looking at some of your notes, and when you go back, even though we've written on the board and explained, it doesn't help you. So this bit here, these are the two lengths that surround the angle. Would you agree? Huzzah and huzzah. Whereas the 165, that is the one that is opposite. So you subtract the length that is opposite. So that would be something that you should put on your help sheet. The other thing that people were then having trouble with was using their calculator. So how do you get rid of the cosine? Cos to the minus 1. So theta is cos to the minus 1 of all of that. Now you should get 23 point something. Some people were using their calculator and then rounding it off to 0.91. That will end up getting you 24 degrees. Wrong! You've got to know how to use your calculator. So please, you must practice that. Now by next lesson, I need you to have attempted, what are we up to? 3. So can you attempt 4, but just 6 questions, just 3 questions. I want to at least see a diagram. So Sienna, I don't want to say or hear, yeah, I got stuck, I couldn't do it. You will draw a diagram, whether it's right or wrong, I don't care. Label, do something. Love your work, love your style.